Right, welcome to this introduction to acids and bases. First of all, we're going to start off discussing the fact that we have 4 different tastes that we can associate with different types of acids and bases. They are sweet, sour, salty, and bitter. And if we pay attention to things really closely, we can actually name a 5th, and that is umami. The first thing we have to know about taste is that there is a long-lasting myth that there is a tongue map which shows us where tastes are. Now, if you take some different types of food, especially say something salty, and put it right on the tip of your tongue, you will notice that you can still taste the salt. There's no such thing as having different receptors in different places on our tongues. The taste receptors are all over our tongue, and this was actually proved false in 1974. For some reason, it is still taught as a fact. Some schools actually still test on it, so it's useful to have a look, but just remember, it is completely and utterly wrong. Okay, the first thing we're going to have a look at is sweet. Now, we should all be very familiar with the taste of sweet things. If you're anything like me, you love different types of sweet things. And to be able to taste sweets, this is actually caused by our sugars, which are glucose, galactose, and fructose. Okay, those are our 3 different types of sugars. And certain types of proteins will also cause us to taste sweet. There are different substances, which means that we have different types of sweet tastes. We can tell the difference between a chocolate in a cake and a bar of chocolate. It is a different taste, which means that there's different substances in there. Next, we have sour. And sour is caused by proteins and the protons which are found in acids. Okay, often people consider the sour taste to be unpleasant. Most people don't like things that are sour. Some of us do enjoy sour taste every now and again. The stronger the acid we find, the more sour the taste. Just a warning, please don't go and taste different types of acids. They can burn you and you will land up in hospital. Okay, you don't want to burn your tongue on acids by trying to see if they are sour. What you can taste is what you can see there. We've got lemons. Okay, we all know that lemons are sour. Okay, and a lemon is an acid. We've got white vinegar. White vinegar is actually a mild acid, but we can still taste the sour there. We've also got things like lime and grapefruit. They're all different types of acids, different strengths, but we can definitely taste the sour in them. Okay, salty. And the salty taste is very easy because it is caused by the presence of sodium ions. Okay, we've done the periodic table hopefully, so we know that sodium is a metal, but we have something called sodium chloride, which is table salt. And that is why we taste salt. There are other alkali metals which can also cause a salty taste. If you look at the periodic table, you will see that potassium is very close to sodium, which also causes us to taste a salty taste because it's so similar. It can react with the same receptors in our tongue. Potassium is a little bit more bitter than sodium though. Right, bitter. This is another taste that is perceived as sharp, unpleasant, or disagreeable. Not many people like bitter. Some of us have acquired the taste for bitter foods, such as cocoa and coffee. Okay, cocoa is what we use in dark chocolate. In normal chocolate, as our milk chocolate and our white chocolates, we add a lot of sugar to cover the bitter taste. Certain people also can't drink coffee without sugar, because they don't like the bitter taste. Being able to taste bitter compounds is a very important evolutionary trait, however, because many naturally bitter compounds are toxic. So we used it in evolution before we had labels that tell us don't taste this, don't eat this. We used to try it with different fruits and leaves and other edible things that we wanted to work out, and we would see if it was bitter. We wouldn't obviously eat it because we would spit it out because it was gross, and this allowed us to avoid many different toxic compounds. Modern days we have cooking and processing, which has allowed us to detoxify otherwise inedible plants, in other words, to take the bitter out of them. Our fifth flavor is what we call umami, and this is actually our savoriness. The word umami is Japanese, which means tasty or deliciousness. This type of taste is often associated with MSG, which has a strong savory flavor. Umami is extremely important in your Asian cuisines because if you have a look at what has the strongest umami tastes, which would be our meats, fish, nuts, mushrooms, they're all very savory tastes. Remember, these are raw nuts, not salted nuts, and these are widely used throughout Asian cooking. Okay, so umami is actually our fifth flavor, and it's our nice, savory, tasty flavor. Okay, so why do we actually have different tastes? Being able to taste different types of food allows us to decide what we want to eat. So when our body is craving something sweet, we shouldn't actually be eating sweets, but that generally means that we should be eating naturally sweet foods such as fruit. Obviously our body is missing something that needs to be replaced by what we can find in fruit. It helps us to identify what is safe to eat and can help us identify acids, bases, and neutrals by taste. Again, please do not taste different chemicals. It's dangerous. They are not meant to go in your mouth. Okay, moving on to acids, bases, and neutrals. So all chemicals can be placed along the pH scale. The pH in the pH scale stands for the power of hydrogen. It is an inverse scale, so the lower the pH, the greater the concentration of hydrogen atoms in that chemical. Okay, so pH of less than 7 means something is acidic. pH of greater than 7 means something that is basic. And a pH of equal to 7 or just off 7 is our neutral. Right, acids. The word acid comes from the Latin acidus, which means sour. It's a nice thing to remember because our properties of acids, they have a distinct sour taste. Okay, many people find it unpleasant. If you get an acid on your skin, it feels rough, it's warm, it doesn't feel nice on the skin. You don't want to put acids on your skin. Okay, they can be very dangerous, especially the stronger you get. They are corrosive, which means that they eat into metals, and they can cause burns, which you actually have to go to hospital to get them treated because we need to neutralize the acid to stop the burning. Okay, if we look at DNA, and DNA stands for deoxyribonucleic acid, we will see that is also a different type of acid. Our acidic foods include sugar, fish, processed foods, cool drinks, and our different meats. Okay, protein is made up of amino acids, and yes, amino acids are acidic. Bases, our different base properties. Remember, B for base is B for bitter taste. Okay, they feel slippery on the skin. You should know this quite well because soap is a base as well, and when we get soap on our skin, it is slippery. Our strong bases can also be dangerous and corrosive. Okay, a strong base is something like drain cleaner, and we should hopefully know that we do not get drain cleaner on our skin because it can burn. Special bases can dissolve in water, and when they are dissolved in water, they have a name which is not base. They are called alkalis. Okay, neutrals obviously act differently to both acids and bases. Pure water or distilled water is a neutral. All water is a roundabout pH 7, but depending on the different chemicals or nutrients that is found in the water, the pH does change. Okay, table salt, sodium chloride, is actually a neutral substance. Most people expect it to be either an acid or a base, but it's not. It's actually a neutral. Right, to test for acids, bases, and neutrals, we use what is called an indicator. Okay, and indicators show results by changing color. We have different indicators called litmus paper, which is actually a paper, and we have different liquid indicators. Depending on which indicator we use and the color reaction we get, we can tell whether it is an acid, a base, or a neutral. Most indicators need to be used together in order to be the most accurate, because not all of them will change between an acid and a neutral or a base and a neutral. If you have a look at the picture, that is actually litmus paper, and the one that says pH and has the numbers 1 up to 14 going in a nice scale there, that is universal indicator paper, and that gives us an estimate of what the actual pH of the solution we are testing is. Okay, we're going to have a look at some different types of indicators. These are just 5 common indicators that are used. There are many different indicators, including some indicators that you can even make at home. So you are welcome to go and have a look on Google all the different types of indicators. If we have a look at this table, in the first column we've got our indicator. Second column tells us what color the indicator is in an acid, which is pH less than 7, the color in neutral pH of 7, and the color in a base, which is a pH of greater than 7. The first indicator we have is called phenolphthalein. I know the spelling is a bit scary, but you'll get used to it. Phenolphthalein only has a color reaction in a base, so it remains colorless in an acid and a neutral. Okay, it's not just clear, it's actually colorless. It's a proper scientific term for it. In a base, it turns a pinky red color. Then we have bromothiamyl blue, and in an acid, it turns a yellow color. In more neutral pHs, it is green, and in a base, it is blue. Then we have our 2 litmus papers. We have red litmus and blue litmus. Now please remember, red litmus to begin with, the color is red. So red litmus in an acid will stay red. In a neutral will also stay red, but it will change to blue in a base. Blue litmus is blue. It turns to red in an acid. It stays blue in a neutral and stays blue in a base. These 2 types of litmus paper need to be used together in order to determine what you have, because it could be a neutral that you don't pick up because you haven't tested the other color paper to see if there's a color change. So remember, your litmus papers you always use together. Last one we have is universal indicator. This either comes in a paper or it also comes in a liquid. So for our acids, we have a red, orange, yellow color. In neutral, it is green, and in a base it is blue, violet, and purple. And those are your color reactions in different types of indicators. And the last thing we're going to look at is a couple of examples of reading indicators. So we have two unknown solutions, and the first solution we have tested it in phenolphthalein, bromothymol blue, red litmus, and blue litmus. And our results is colorless in phenolphthalein, yellow in bromothymol blue, our red litmus stays red, and our blue litmus turns red. Therefore, by taking into account all the color changes there, we know that our first solution is an acid. Our second solution, we have tested it in phenolphthalein, bromothymol blue, red litmus, and with a universal indicator. Our phenolphthalein is colorless, bromothymol blue turns to green, our red litmus stays red, and our universal indicator also turns to green. This shows us that we are dealing with a neutral substance because of the color changes we have seen from the indicators. Okay, remember, we cannot make a definitive answer from one indicator unless we are using indicator paper of universal indicator or the universal indicator liquid that has pretty specific color changes for the pH that you are dealing with. If you buy universal indicators, you will actually get a table that shows you what color which pH will change the indicator to. And that is the end of our introduction to taste and acids and bases and neutrals.